Have you ever wondered what makes a robot actually work? A robot can move, detect objects, process information, communicate with other devices, and perform different tasks. But it doesn't do all of these with one component. Behind every functioning robot are different parts working together. These parts can be organized into what we call robotics modules.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
A module is like a building block of a robotic system. Each module has a specific function, but when they work together, they create a complete and functional robot. So in this lesson, let's explore the major robotics modules and understand how each one contributes to the robot's operation. What is a robotics module? A robotics module is a component or subsystem designed to perform a specific function in a robotic system. Instead of designing a robot as one complicated unit, engineers divide its functions into different modules. For example, one module provides power, another detects the environment, another processes information, another creates movement, and another allows the robot to communicate with other devices. This modular approach makes robots easier to design, troubleshoot, repair, modify, and upgrade. Think of it this way. A robot is like a team. Each member has a different job. When everyone performs their role properly, the entire team works effectively. The same principle applies to robotics. 1. Power module. Let's start with the power module. Every robot needs energy. The power module provides and manages the electrical power required by the different components of the robot. It may include batteries, power switches, voltage regulators, and power distribution circuits. For example, a battery might provide 12 volts, while a particular sensor may only require 5 volts. A voltage regulator can help provide the appropriate voltage to that component. The power module, therefore, doesn't simply provide electricity. It also helps distribute and regulate power throughout the robotic system. Without a reliable power system, the other modules cannot function properly. So remember, no power, no robot. 2. Sensor module. Next is the sensor module. Sensors allow robots to gather information about their environment. You can think of sensors as the robot's senses. For example, an ultrasonic sensor can measure distance. An infrared sensor can detect objects or help a robot follow a line. A light sensor can detect changes in brightness. A temperature sensor can measure temperature. A camera can capture images and video. The sensor collects information and sends that information to the controller. For example, an obstacle-avoiding robot might use an ultrasonic sensor to detect an object in front of it. The sensor doesn't decide what the robot should do. It simply provides information. The decision comes later from the controller. So, sensors detect. 3. Controller module. Now we have the controller module. This is one of the most important parts of a robotic system. The controller receives information from sensors, processes that information, and determines what the robot should do. A microcontroller such as an Arduino-compatible board, ESP32, or similar controller can serve this role in many educational and embedded robotics projects. Let's return to our obstacle-avoiding robot. The sensor detects an obstacle. The information goes to the controller. The controller checks the program. The program might say, if an obstacle is detected, stop and turn. The controller then sends the appropriate commands to the actuators. So the controller acts like the robot's brain or decision-making center. Remember, sensors provide information. The controller processes the information and makes decisions. 4. Programming module. But how does the controller know what to do? That's where the programming module comes in. A robot needs instructions. These instructions are written as a program. For example, if the distance sensor detects an obstacle that is too close, stop the motors, turn left, then continue moving. Programming allows us to create the logic that controls the robot's behavior. This is why robotics is not only about hardware. A robot can have excellent motors and sensors, but without appropriate programming, it may not know how to use them effectively. In simple terms, hardware gives the robot its capabilities. Programming tells the robot how to use those capabilities. 5. Actuator module. Next is the actuator module. If sensors allow the robot to detect, and the controller allows it to process and decide, actuators allow the robot to take action. Common actuators include DC motors, servo motors, stepper motors, and other mechanisms. For example, a DC motor can rotate the wheels of a robot. A servo motor can move a robotic arm to a specific position. An actuator converts electrical commands into physical action. So remember this sequence. Sensors detect, controller decides, actuators act. 6. Communication module. Now let's talk about a very important module, the communication module. A communication module allows a robot to exchange information with other devices or networks. It can allow the robot to receive commands, send sensor data, report its status, or communicate with another system. And there are different ways for a robot to communicate. 3 common examples are Bluetooth, Wi-Fi, and GSM or cellular communication. Let's look at each one. Bluetooth module. Bluetooth is commonly used for short-range wireless communication. A popular example in Arduino-based projects is the HC05 Bluetooth module. Imagine a robot car controlled by your smartphone. You press the forward button on your phone. The phone sends the command through Bluetooth. The Bluetooth module on the robot receives the command. It passes the information to the microcontroller. The microcontroller processes the command and tells the motor driver what to do. The motors then move the robot forward. The communication flow looks like this: smartphone, Bluetooth module, microcontroller, motor driver, motors. Bluetooth is useful for smartphone-controlled robots, robotic arms, remote control projects, and wireless sensor monitoring. One important characteristic of Bluetooth is its relatively short communication range compared with cellular networks. So Bluetooth is a good choice when the controlling device and the robot are relatively close. Think of Bluetooth as connect me to something nearby. Wi-Fi module. Wi-Fi also provides wireless communication, but it is especially useful for connecting a robot to a network. Some microcontrollers, such as the ESP8266 and ESP32, have built-in Wi-Fi capabilities. Imagine a robot monitoring a greenhouse. The robot collects temperature and humidity data. The microcontroller processes the readings. Through Wi-Fi, the robot can send that information through the local network to a computer, smartphone, or server. The basic communication path could be robot, Wi-Fi, router, network, computer, or smartphone. With the proper setup, Wi-Fi can also support internet-based robotics and IoT applications. For example, a robot could have a web interface that allows a user to monitor or control it. Wi-Fi is therefore useful for IoT robots, remote monitoring, web-controlled robots, camera-equipped robots, and sensor data systems. So if Bluetooth is commonly used to connect nearby devices, Wi-Fi is useful when we want the robot to become part of a network. Think of Wi-Fi as connect me to the network. GSM or cellular module. This is different from Bluetooth and Wi-Fi because it communicates through a cellular mobile network. Examples include modules from the SIM800 series and other cellular technologies, depending on the module and available network service. A cellular module can allow a robot or embedded system to communicate through mobile networks. Depending on the module, network, and service, it may support functions such as SMS, voice communication, mobile data, or other forms of cellular communication. Imagine a robot monitoring a remote agricultural area. The robot detects an unusually high temperature. The sensor sends the information to the microcontroller. The microcontroller determines that the temperature has reached a critical level. It then instructs the cellular module to send an alert. The communication flow could be sensor, microcontroller, cellular module, cellular network, user's phone. This is particularly useful when the robot is operating somewhere without access to the local Wi-Fi network, but cellular coverage is available. For example, agricultural monitoring, remote environmental monitoring, security systems, and remote alert systems. Think of cellular communication as reach me through the mobile network. Bluetooth versus Wi-Fi versus cellular. So how do we remember the difference? Think about their typical roles. Bluetooth is commonly used for short-range connections between nearby devices. Wi-Fi connects devices to a wireless network. Cellular communication connects devices through a mobile network. In simple terms, Bluetooth, nearby. Wi-Fi, network. Cellular, mobile network. And remember, the actual range, speed, power consumption, and capabilities depend on the specific module, technology, and environment. 7. Mechanical module. Finally, we have the mechanical module. This includes the physical structure and mechanisms of the robot. Examples include chassis, wheels, gears, robotic arms, joints, and mechanical brackets. The mechanical module provides the robot with its physical structure. For example, the chassis holds the electronics. The wheels allow the robot to move. Gears can change speed or torque. And robotic joints allow robotic arms to move. Even with excellent electronics and programming, a robot still needs proper mechanical design to perform its task effectively. So the mechanical module is essentially the robot's physical body. How all the modules work together. Now let's put everything together. Imagine an autonomous obstacle-avoiding robot. First, the power module provides energy. The sensor module detects an obstacle. The controller module receives the sensor information. The programming module provides the instructions for what to do. The controller decides that the robot needs to turn. The actuator module activates the motors. The mechanical module converts that motor movement into physical motion. And if the robot needs to report its status to another device, the communication module sends that information. So we have power, sense, process, decide, act, communicate. All of these modules work together. That's what makes the robot a complete system. Why modular design is important. Why don't engineers simply build everything as one giant system? Because modular design makes robotics easier to manage. If a sensor stops working, we can focus on the sensor module. If the robot needs wireless communication, we can add or replace a communication module. If we need stronger motors, we can modify the actuator system. If the robot needs a different behavior, we can modify the program. This makes robotic systems easier to build, test, troubleshoot, repair, and upgrade. In other words, modular design gives engineers flexibility. A simple way to remember the modules. Here's a simple way to remember the major robotics modules. Power provides energy. Sensors collect information. Controller processes information. Programming provides instructions. Actuators create action. Communication connects the robot. Mechanical provides structure and movement. Together, these modules transform separate components into a functional robotic system. Hugot. Parang buhay lang. Hindi naman lahat ng tao sa buhay natin pare-pareho ang role. May nagbibigay ng energy, may nagbibigay ng direction, may nagsasabi kung may problema, may tumutulong sa atin gumawa ng desisyon, may tumutulong para makagalaw tayo. At may mga taong nagsisilbing communication bridge para hindi tayo tuluyang mawalan ng connection. Kaya tandaan, a robot doesn't become powerful because of one module. It becomes powerful because its modules work together. Ganun din sa buhay. Hindi mo kailangang gawin ang lahat mag-isa. Sometimes, you just need the right people, doing the right things, and working toward the same goal. Quick recall. Before we finish, let's have a quick recall. Which module provides electrical energy? Power module. Which module detects the environment? Sensor module. Which module processes information? Controller module. What tells the robot what to do? The program. Which module creates physical movement? Actuator module. Which module allows the robot to communicate wirelessly? Communication module. And which module provides the robot's physical structure? Mechanical module. And for communication technologies, Bluetooth, nearby communication, Wi-Fi, network communication, cellular, mobile network communication. So, robotics modules are the building blocks that allow a robot to sense, think, communicate, move, and perform tasks. Each module has a different responsibility, but the real power of robotics comes from how these modules work together. Remember, sensors help the robot know. Controllers help the robot decide. Actuators help the robot act. Communication modules help the robot connect. And the mechanical system helps the robot physically interact with the world. I'm Ma'am Hugot, and remember, in robotics, every module has a role. And just like in life, when every part works together, the whole system becomes stronger. See you in our next robotics lesson.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.